In this presentation, you will learn about the role of the Domain Name System, or DNS, in the network infrastructure. At the end of this presentation, you will be able to explain the role and benefits of DNS in the network infrastructure, define the key components of DNS, discuss the DNS domain name space, discuss DNS zones and zone transfer, discuss DNS name servers, explain how the host's name resolution process works, and explain forward lookup queries. In Transmission Control Protocol, Internet Protocol, or TCP/IP networks, many components are used to ensure that each TCP/IP host can communicate with other TCP/IP hosts and access network resources. After the introduction, we will cover the key components of DNS and how the host's name resolution process works. DNS is a distributed database with a hierarchical structure that can serve as the foundation for host name resolution in a TCP/IP network. DNS is used by most internetworking software, such as electronic mail programs and web browsers, to locate servers and to resolve or map a user-friendly name of a computer to its IP address. For example, a computer name such as webserver1.training.microsoft.com maps to an IP address of 192.168.0.18. Although DNS is most commonly associated with the Internet, private networks also use DNS because of the following benefits. Convenience. User-friendly names are easier for people to remember than numerical IP addresses. Consistency. IP addresses may change, but the server names can remain constant. Simplicity. Users need to learn only one naming convention to find resources on either the Internet or on an intranet. Now let's take a look at key components of DNS. To understand how DNS maps to IP addresses, you will need to understand the following three components: DNS domain name space, zones, and name servers. The DNS domain namespace provides the structure of a DNS distributed database. Each DNS domain has a unique name. The DNS domain namespace has a hierarchical structure. The root domain is at the top, and it is represented by a period. Below the DNS root domain, the top level or first level domains are organizational types. For example, org is used for non-commercial organizations, com is used for commercial organizations, edu for educational organizations, and au for geographical designations such as Australia. Second-level DNS domains are registered to individuals or organizations such as Microsoft.com, the Microsoft Corporation domain, or Stanford.edu, the Stanford University domain, or gov.au, the domain for the Australian government. Second-level DNS domains can have many subdomains, and any domain can have hosts. A host is a specific computer within a domain, such as Computer 1 or Web Server 1 in the training subdomain of the Microsoft.com domain. A fully qualified domain name, or FQDN, describes the exact relation of a host to its DNS domain. DNS uses the FQDN to map a host name to an IP address. For administrative purposes, DNS domains can be organized into zones. As you can see in this example, a zone is a discrete and contiguous area of the domain name space. One reason to divide a namespace into zones is to delegate authority for different portions of it. One very large domain could be difficult to administer. The name-to-IP address data for computers located in a zone is stored in a zone database file on a DNS name server. One name server holds the primary zone database file for a zone. That name server is said to have authority for making changes to the zone file. A copy of the zone file may be stored on other servers to balance network load. These copies are referred to as secondary zone database files. The secondary zone database files are updated regularly from the primary zone database file by a process called zone transfer. Therefore, either server can answer host's name resolution queries for that zone. The next section describes how name servers resolve or map user-friendly names to numerical IP addresses. The host name resolution process involves sending a query to one or a series of name servers to locate the IP address of the requested computer. The query contains the FQDN of the requested computer. The name servers use a computer's FQDN to locate its IP address. This query is called a forward lookup query. A forward lookup query is a request to map a name to an IP address. This example shows a forward lookup query from a client to find the IP address of Web Server 1 in the training.microsoft.com domain. The client queries its local name server for the IP address of webserver1.training.microsoft.com. The local name server checks its zone database file to see if it has authority for that domain. It does not have authority, but the name server does contain information that points to the root name servers. The local name server will now begin a search for the name server that has authority for the domain training.microsoft.com, starting with the root name servers. The local name server sends a query to the root name server. The root name server contains IP addresses of the name servers for the top-level domain, COM. The root name server sends those IP addresses back to the local name server, which then queries a COM name server. The COM name server receives the query and responds with a referral to the Microsoft.com name servers. The local name server sends its request. The Microsoft.com name servers have the zone database files that contain the name to IP address mapping information for Web Server 1. The Microsoft.com name server passes the requested IP address to the local name server. The local name server passes the IP address for webserver1.training.microsoft.com to the client. Then the client establishes a TCP IP connection with Web Server 1 and data can be transmitted. A local name server may send out numerous queries to finally resolve an FQDN to an IP address. In this presentation, you saw the key components of DNS. The DNS domain name space, DNS zones and zone transfer, DNS name servers, how the host name resolution process works, forward lookup queries, and why DNS is an integral part of client-server communication in TCP/IP networks.